Today we are going to figure out what the rest of these trig functions look like. And we're going to start off here with tangent. And we'll do the same thing. We'll plug in some points and connect the dots. So let's start here at minus pi over 2. And right, tangent of theta is supposed to be the y over the x. And I actually have our unit circle over here. So if we were to go to minus pi over 2, that would be rotating from here to here. So we're looking at this point right here. And if we do y over x, you can see that we're going to have minus 1 over 0. That's undefined. So actually, the first point that I chose is undefined. Let me scoot back up here. There we go. Let's just write in maybe a u here. And I'll just write a little note over here. U for undefined. And that's not a normal abbreviation for undefined. In fact, I don't know that there is an abbreviation for undefined. It's just that's what we have room for here. Let's go to minus pi over 4. All right. So if we rotate minus pi over 4, that puts us right here. And so we're looking at these two x and y's. And notice they're the same other than the sign. So if you do y over x, we're just going to get minus 1. Right, and we can keep doing this. The next one will be 0, and then 1, and then it'll be undefined again, and then minus 1, 0, 1, undefined. And you might be seeing that there's a pattern now. Okay, and we are going to follow it. All of these places where you see the U, that's actually going to be the spot of a vertical asymptote. Let's maybe sketch that in here. And our next one was at 3 pi over 2. And if you notice here, in between each asymptote, or each pair of asymptotes, I should say, that we have split that interval into 4 pieces, just like we did really with sine and cosine, other than, right, we didn't have vertical asymptotes, but we were thinking about splitting parts of our graph into 4 pieces. Okay? And these x values here all happen to correspond to y values that we can easily plot, just like with sine and cosine. And we'll figure out how to pick those nice x values. All right, next let's plot some points. Let's do the zeros. Those are easy. So the zeros are always going to be directly in between the asymptotes. And of course, if we have some sort of a vertical shift, it's not going to be a 0 anymore. But the center of the shape that we're about to make will always be directly in between the vertical asymptotes. And then next here, let's do minus pi over 4. Put the point there. And at pi over 4, we get another point here. And we could do the same thing in between these other two asymptotes. This looks like about minus 1 and 1. And now let's connect the dots. All right, and again, this pattern, it's going to keep continuing in both directions. So this is not the entirety of tangent, but it's what it looks like. All right, the next thing that we want to fill in here is the period, the domain, the range. And so again, you can actually see the period here is pi. If you were to subtract any of these endpoints of where the asymptotes are. So 3 pi over 2 minus the asymptote before it is pi over 2. And this just gives us 2 pi over 2, which is pi, the period. And the same thing will happen if I tried that with these two sets of asymptotes. All right, well, period is pi. And since we have these vertical asymptotes, you can see that our function is growing without bound as we get closer to, say, 3 pi over 2, and it's decreasing without bound as we get closer to pi over 2 over here. Okay, so the range is actually all real numbers. And the only thing that's really a little odd here is the domain, because every pi units we have another vertical asymptote. And there is actually a compact way we can write the domain here, but we're not going to get into that. We'll just write it in kind of a lengthy way just because it's a little bit easier. So our domain is still all real numbers except really where those asymptotes are. Okay, so if n is an odd number and we multiply it by pi over 2, that is going to be the location of an asymptote and also a place where our function is undefined. All right, let's do the same thing here with cotangent. And if you want, you can pause the video for a second and try and fill in all these x and y values, or actually just outputs, y values here. And I'm going to go ahead and fill them in. So our first one's 0, -1, undefined again, 1, 0, -1, undefined, and then again, we should be at 1 and then 0. All right, and we're using the idea here that cotangent of theta is x over y, using this unit circle over here. All right, and let's start plotting some of these points. I'm actually going to skip out on plotting these two because it's actually only half. This part here is only half of a period, and it's going to look a little funny if I graph that. So I extended this in this direction a little bit. But we'll be following the same pattern. But so you can see at x equals 0, this time we have a vertical asymptote. And you know what? I won't put a dotted line there this time just because that's where our y-axis is. But our other vertical asymptote that we can see here is at x equals pi. And remember, cotangent and tangent have a period of pi. Maybe I'll just write it in right now. They both have a period of pi, so the next vertical asymptote is going to be at 2 pi. And in fact, once we start looking at transformations of tangent and cotangent, it's always going to be the case that these vertical asymptotes are the period apart. Next, let's put in a few points. Let's do this pi over 4 is 1 at pi over 2. The output's 0. At 3 pi over 4, the output is minus 1. And then if we make our way over to 5 pi over 4, we see that it's 1 again. And then at 3 pi over 2, it's 0. And then you can guess probably here, it's going to be negative 1 at 7 pi over 4. And you can verify that if you want. And now let's connect those dots again. All right, now one thing you might be wondering a little bit is these places where I've said that the functions tangent and cotangent are undefined, how do I know that there's actually an asymptote there? Well, let's go back up just for a moment, and we're going to look at tangent and the unit circle to see if we can kind of justify why this is the case. Okay, so let's think about this pi over 2 here, okay? So if we come over here to pi over 2, we're thinking about this spot right here. Okay. Now you can see if I were to do the y over the x, right, tangent of pi over 2, I'm going to run out of luck. This will be undefined. I'll have 1 over 0. Well, let's maybe scoot ourselves this way a little bit, just a little bit. Okay? And actually, let's maybe even imagine ourselves moving along this unit circle, getting closer and closer to this point right here. Okay. Well, if we imagine that, then in the numerator, we know that we still have approximately 1, right? We're getting closer and closer to a y value of 1. And in the denominator, we have this small number. And you might remember if you do anything over a small number, it's going to make it really big. Okay. And of course, if one of those two numbers is negative, we'll end up with a really large negative number. Okay. But point is, 1 over a small positive number is going to give us a large number. And the closer that we move towards this point, the smaller this number that I have arrowed to gets, which means the larger that this one gets. And if this argument doesn't prove to you that this is going to have that vertical asymptote there, you could actually try and plug in, say, tangent of pi over 2, and just take away some really small number. And you should be able to see that this is equal to a large number. And you can keep making this number that you take away smaller and smaller and smaller. That way you're getting closer and closer to pi over 2.